Welcome back. Hope everyone's weekend went well. Mine certainly went well with studying and also some leisure. Unfortunately, all the hockey I played or watched was resulted in a loss. On Thursday, that was the San Jose Sharks losing 4-1 to the Calgary Flames. On Sunday, that was the San Jose Grizzlies losing 3-1 to the Royals. Anyways, we're not here to talk about my beer league slash hockey. We're here to talk about data compression. And my total hours spent was 5 in total, 2 hours on Friday. That was mostly setting up stuff to look over the homework. And I looked over the homework. On Saturday, I reviewed lecture 1.1 and watched lecture 1.2 and took notes on Sunday. So those were my hours and the progress that I made through the course material so far. And yeah, so that's the course material so far that I've made through. I will continue to do the homework once and really make an effort on homework 1 after I finish 1.5. So that's kind of my progress so far into EE 274, Intro to Data Compression. Now, 1.1 is an introduction to lossless compression. And so in this lecture, we talked about what lossy and what lossless is. Lossless is kind of like what it sounds. When we compress the data, we don't lose any information that corresponds with the data that came in. The data out also comes out the same. So we're just being able to save space with lossless compression. With lossy compression, we're giving a probability distribution, and because the probability of certain bits are so low, we end up just omitting them altogether. And so the first part of the course covers lossless compression and getting the basics of that before we start moving into lossy compression, which kind of depends on the human eye, the human aspect. So the other part of the lecture also covered the basic basic strategies for compression, specifically introducing prefix-free codes, or otherwise known as instantaneous codes, or prefix codes for short. So the definitions and probability, so things that were covered, what prefix codes end up doing is able to introduce a variable bit length. So instead of it being fixed bit, like in this alphabet where we only have 4 characters, instead of it going 0, 0, 0, 1, 1, 0, 1, 1 for all 4 codes, which would be an encoding of 2 bits per symbol, instead we're moving to a variable bit length with A having 1, B having 2, C and D both having a bit length of 3. And so we are basically able to then be able to use the compression ratio and the equation for the compression ratio to find what the average bit length of our codes would be, which take my word for it, this one ends up being about 1.53. So that was all of 1.1. 1.2 expands on prefix codes and how to really decode them. So it builds on this idea and defines lossless compression in a way where lossless compression is or a lossless set is a set of codes that are uniquely decodable. And so what that means is that one code does not overlap with another code. So in this case, we know that this set is a uniquely decodable set, and we also learned that prefix-free codes are also uniquely decodable. So moving on, we also want to know what makes a good code. And so kind of what makes a good code is this key idea is that the probability of symbol 1, if that is greater than the probability of symbol 2, then the length of code 1, of symbol 1, should be less than or equal to the length of symbol 2. And another tool that we can use in our tool belt is a prefix tree. Basically, the prefix tree will tell us what our code is. So instead of using something like this that can be either done with a hash table, we can actually create a tree and use the path that it takes to get to a certain node to actually, or a certain leaf rather, actually denote what our code is going to be. So if we start at the root and we go left, we know that the code is 0. If we have to go right, we add a 1. If we go left, we add another 0, et cetera, et cetera. So that we were able to use this. And so we also talked about optimal code lengths. So we have the length of the symbol is denoted by the upper limit of log base 2, 1 over the probability of the symbol. So that means if I have the probability of 1/2, it being 0.5, then I will have an optimal length of 1. So that's kind of what we discussed in this. We also talked about Shannon codes, which I think briefly covers using the code length and the symbol to get a certain path. And another important thing is that we know that the leaf node says that that's where the symbol is going to indicate that's where the symbol is going to be, and that if we go any further down the tree, like let's say I want to go off of this, and we'll say this is E, and this is something else, we'll just say F. E and F are not uniquely decodable, as it would be a prefix of A. So we know that we can use a tree in order to find different prefix codes. So that is my learnings for 1.1 and 1.2. What is up next is 1.3, which I believe is craft inequality. 1.4 I have not looked up yet, but I will be going through the course notes and the lectures for that. There is also a paper that was mentioned in 1.2 that I have to go through still. And then if there's still a lot of time, then we will go for 1.5. So trying to make 3 lectures in a week, as well as read a single paper. And I'm going to say that my target total for studying is going to be, I was going to say 14 hours, but we're going to just go and say 15 hours. We'll be on the bright side. So let's try to reach the target total for studying this week, 15 hours. It's about, we can add 3 on Thursday, maybe 1 on Friday. Keep Saturday the same, 2 on Sunday. Call it a nice 15 hours week, and get more things done. So that is my update for the week. Stay safe out there, and if you like this video, please feel free to hit like. If you really like this video, please hit subscribe. It helps the channel a lot. And thank you again for watching. Bye.